Hello, everyone. Welcome to our second edition of WebinAI. My name is Paula. I'm CEO and co-founder of LinkedAI, where we specialize in the generation of training data for computer vision and generative AI applications. Thank you all for joining us today in this second edition of our event. In this first day, we will focus on the creation of images with artificial intelligence and the application of machine learning and deep learning in the healthcare space. Well, thank you. And for the ones that just are joining, thanks for being here with us today. I will introduce our first speaker, Carlos Alarcón, a system engineer and master in ICT management, renowned in the field of data science and artificial intelligence. Carlos has held various roles in the business sector. At the online education platform Platzi, he contributed to the company's growth by creating relevant metrics, implementing new AI based features for the product, and fostering a data driven culture. You may know him best for leading the School of Data Science and Artificial Intelligence at Platzi. Let's welcome Carlos Alarcón with his talk, Images of the Future, the Transformative Impact of Artificial Intelligence on Visual Generation.
Thank you for that introduction. It's a pleasure to be here. So I'm going to share my screen.
Sure. Take it from here, Carlos.
Okay. I think we can see my slides right now. Perfect. So text to image is a revolutionary technology. Basically, I can create any image in any style in a second. But why text to image? First of all, we need to talk about text to text. And this is another file of the technology of the big wave of AI. And text to text is basically that. I can prompt or I can write any text and or the artificial intelligence is going to generate any text that satisfies that prompt. Basically, in text to text, we have ChatGPT, BART, or now Gemini, Cloud 2.1, and all those LLM or large language models that we have already. This is text to text, and this is the base there that we have now text to image, because all the transformers technology behind the text to text artificial intelligence is the base for build text to image. And text to image is basically that. We have artificial intelligence models that convert text to image. The representation or the description of text is going to represent by an image in any side of any style. What can I achieve with that? Basically anything. We can do magic designs like this. We can do some characters or some fiction guys like that. We can do any photorealism images like that and different kind of styles of pictures. We can do some magical landscape like that and magical creatures like we see. And also we can do non-human persons or not human characters like this dog, and see the details of the texture, the different things that we can do. And also we can do photorealisms. This is just a photo with a specific camera and specific things that we can create, and all in seconds. We can create a universe, an entire universe. And this is just a few examples that we can do. Of course, all these images are very old, but we can create a lot of things. Is the point that we can create something like that? And the realism of the photos is so big, even people can difference if it's real or is AI. And this is the point that we have right now. Even those two persons doesn't exist really, just image generation but an AI. Also, we can create marketing, branding, or something like that, because it's not just create images, it's not just create animals, it's not just create landscape. We can create branding and marketing design from scratch in seconds, something like that. linked AI made by cookies or made by a neon or like a sketch in pencil or something like a graffiti in a wall. And this is a big opportunity of marketing or branding or logo in any place, in any style, in just seconds for generation. And this is the potential of artificial intelligence or generative AI in image generation. We can also train some models like Stable Diffusion for teach how to draw my face, something like that. It's just fine tuning techniques like that. This is built in, I don't know, 15 minutes. The artificial intelligence can recreate my face. And it's not just my face. Think that you create a new product, a new branding, new character, or something like that. We can teach the artificial intelligence models how to recreate that totally from scratch with a few photos of the product. And this is really awesome. In Platzi, we use all these artificial intelligence models and all that we have for marketing, for improve of design team, for improve our marketing team, and that is one of the best campaigns that we have in the past year, in April actually. We all know Barbie. Barbie have a big marketing sites for the movie, and we want to create a campaign based on Barbie. Because Barbie is in this moment was talk about everything, but everyone. So these campaigns was created in a few seconds, and it was one of the most profit campaigns that we have, and it's just artificial intelligence generation that image. Also in Platzi, we have a lot of courses that the teachers or the people that is teaching are for real avatars or artificial intelligence. And this is one of the next steps that we are doing in Platzi. Use all these artificial intelligence model generate person and teachers that the student want, and it's just a way to improve our experience in a classroom. And this is we can create, of course, image generation, but we can also edit images. We can create a marketing branding or marketing strategies based on artificial intelligence, character designs from a video game, for a campaign, for everything we want. We can do a total storytelling strategy based on artificial intelligence and image generation. We can do some slides, and we can defeat the creative block. And this is just a few uses that we have of artificial intelligence. How quickly is this processing? Something like that. We have DALI, the first version in 2020, I guess. Yeah, in 2020. And DALI 2 in 2021. And this is the improvement. In less than 1 year, we have that improvement. And a few months later, we have that, DALI 3, um, DALI 3. And this is a big uh, technology that is growing so fast. Think that in a few months, we improving the result or the generation of the AI in this way. And this is awesome. And this is already happening. Even today, the stability AI video create a new model called Stable Diffusion 3. And this happened today. So how does text to image works? Basically, we have that, and this is the architecture of Stable Diffusion. Something like I have a prompt, a description, I have an artificial intelligence that can draw or generate images, and I have the result. We were going to talk about this. So uh, it's basically two parts: a text encoder and image generator. A text encoder is called clip, and clip is just a representation of a model of this called transformer architecture, but have the representation of a text and how is the representation in a pixel space. It's mean an image. And this is it. We have some text, we have some image, and how we can encode or we can bring all this in embedding or vectorial space. And this is the result. I have a description of an image generated by AI. And we can do the same in the opposite way. Basically, we need this: a lot of photos with a lot of descriptions. And I mean a lot. Stable Diffusion 2.0 was created by Lion Sync 5B. It means 5 billions of images with any description. And this is a lot of data that is just passed through an artificial intelligence models and learn how to represent the language with the images. And this is the text encoder. The second part is an image generator. And this is the big deal in the image generation. It's called diffusers. Basically, a diffusers take an image and constantly add some noise at the point that an image is just noise. And then we can throw back in a Markov change, and the artificial intelligence diffuser learn how much noise I need to uh, delete from the image in every steps for return to the original image. And this is brilliant because we can part from total noise, and basically delete in every step a part of noise for create a image of high resolution. And this is the secret of all the image generation. We have also a unit, but that is basically reduce the dimensional of all the samples of the vectoral representation of the image for improve the velocity, or improve the how we can do that. This is a big level of how diffusion architecture works. We had a pixel space that is an image, basically. And we have an encoder. We saw that before, that the encoder is clip, a representation that take the pixel space and bring into a vector space that is easier to work. And it's just the unit for step by step delete the noise that we have in any image for obtain in the final step a decoder that is the representation of an image. Is all good in that? No. We have a lot of things for work, like Greg Rudowski and digital artist is create a campaign called Not to AI Generated Images. Of course, he is a digital artist. Already we have models that can clone or copy his work in a few seconds. So we need to work on how these models is going to use for real help all the artists, photographers, designers, and everything. And it's not just like take apart to his works. So right now I'm going to see some of the examples that we have right now. This is DALI 3, is a free version of the OpenAI model. We can just, I don't know, give me an image of a dog with a hat in a beach. Just a prompt. This is pretty fast. We can 15 credits for any prompts that we want to create. And this is reshared daily. And that's it. That is pretty cute. And of course, we can do that photorealistic style. We can specify that we want a photorealistic style or something like that. So let's go to see. Ah, and meanwhile, this is the thing that I saw you before, that I told you before. Today, Stability AI and EMAT launch Stable Diffusion 3. And this is pretty cool because it's a model open source, totally open, totally free, that we can use as we want. We're going to see some examples that we can do in a commercial models like that. And this is something that we can create. And I'm going to I'm going to take this and this is actually a cell diffusion in the version 1.5. It's an old version, but it works for me. I'm going to generate any other image, and yeah, we have that dog. But this is a open source models, and as an open source model, have a lot of features that commercial model doesn't have. And this is ControlNet is one of them. We can just let's going to see that. Going to okay. I'm going to download that image. Now I'm going to open that image. In ControlNet is basically a model, an artificial intelligence model that literally control the output of the stable diffusion generation. And this is something easier like that. We're going to use Kenny. Kenny is a model that detect all the edges in an image, something like that. And we're going to see image of blue dog and a red hat. So it's going to see if this work. It's just again, it's just a model that take all the edges of an image. It's going to take a while, but it's interesting because I can give an image as a reference, and the model part based on that reference is something like that. All this is the edge map of an artificial intelligence model. Basically, on that image, we can create that. And this is pretty cool. We can do that in DALI 3, we can do that in Midjourney. It's just as it's pretty cool that we can do with ControlNet. And we had a lot of models. We have OpenPose is basically a model that take a pose, take a literally, let's going to see something like this is me basically. Let's going to see astronaut. Just a photo of an astronaut. And this is going to take a while also. And this model that is also ControlNet control the pose. Is basically the edges of the figure that a human is, just like that. This is it. And this is awesome. Think all the possibility in magazines or a fashion model work or something like that. It's just with the pose, and we cannot, I don't know, um, an image of a cowboy. And again, this is fine, and this works just for an open source models, and we can do that here. We can do that in DALI 3. We can do that in another models like Midjourney. That Midjourney have a big quality. I think it's better even than DALI 3, but we lose control. And the open source stable diffusion make me control. We're going to do something else. It's just for show the power of control net on the artificial intelligence models. This is an instant of Hugging Face that we can recreate photos basically with just one photo and control net. This is photo of a man. Let's go to see that. Yes, Spring Festival. Let's generate. Uh, this is executing in the Hugging Face servers, so maybe take a while, and sometimes it's just down. So, but we can do that in the image generation process. Here is me, just one photo, one short and simple prompt, and the rest is a control net network, a control net model for create something like that. And that's me in a spring festival. Maybe we can do something, I don't know, another kind, another style. And again, this is a model that can replicate my face and my pose. And it just take a few seconds to do that. And again, it's just for the power of the open source and the community. And this is totally open source. We can download the models, download the weights, and make it happen. Just I'm going to wait a little bit. And meanwhile, I just want to show, let me see. Yeah. Again, Stability AI have a lot of products and a lot of improvements. Even we have something like reimage or cleanup, or let me see. This is a Stable Diffusion XL Turbo. Nah, that's pretty cool. Stable Diffusion Turbo is basically image generation in real time. A dog with a hat in the beach with some gloves. Think about it. It's basically as I can write, the image generation process can create. And this is just the beginning. In a few months or something like that, we can create anything we want in real time. And think about the possibilities of that. Think about how we can do that in a medical field, education field, in political field, social field, and this is awesome. And wow, I think I have a question here. What do you think about deepfakes? Is part of the real impact of these models, and this is a real concern. It's mean we can create avatars so realistic that we can see or we can notice if it's an AI or like this. Is this an AI or this is for real? And it's part of the alignment or the artificial intelligence right now. We have a lot of efforts for OpenAI, for the people of Midjourney in create watermarks and something like that, but the way is long and we need to do that question everything for all the laboratories, all the open source models and that. But I think we can control that. I think the society is going to learn to check twice if something is real or not, and that's gonna happen. Just I actually I went to a photo of Elon Musk talking about deepfakes in the space with a Tesla. Yeah, it's not pretty cool, but it's work. So this is it. We have a lot of examples here in Turbo, here in ControlNet, in Stable Diffusion, Midjourney, um, DALI 3. Also, all of this works in ChatGPT Plus, and we can interact with the image that was generated. But I think my time is done. So I don't know if we have some question or something like that.
Yes. Hi, Carlos. That was really, really interesting. I I think you look great in your flower attire. The images were
Thank
very,
you.
very cool. Very cool. I think we have some questions, but we don't have much time. But I would like to know what's your opinion on how this could impact the film industry. Like this is very, very controverted right now because people
Sure.
think they are going to lose their jobs, especially in the film industry and in the content generation. So what's your view on this point?
Yeah, it's mean in every technology does have this potential. Of course, have an impact in employments. It's mean a few years ago we have work that is that guy that control the elevator. I don't know what is
Yeah.
his name. This work is done because we have automatization in those elevators, and this is part of the improvement. This is part of the how we grow as society. I don't think it's strange, but those models don't don't create. Those models are not creative, and this is strange because I mean I can ride a pink elephant surfing in the sky, and that model makes that happen, but it's not really create. It's just improve, or it's just improvement the way that we teach and that we train of this data. For real, the only the only we as humans are the only that are real creative, and the work of designers, the work of the creative file, the work of marketing, in the, everything else is not create image. It's create the representation of his brains, of this all this creativity. And
Yeah.
this is the real thing that we have as humans. So the artificial intelligence never is going to replace the creativity of the humans.
Yeah, yeah, I think you are correct. I think that's right. Like we can be very creative with the prompts, for example. We can be very creative of what we want to see and
Exactly.
look at the AI as a tool to
This is
improve
just a
our work.
tool.
So yeah, I think we're on the same page here. I think we have time for one more question. I have here Daniel. What is your opinion on the issue of copyright of the images generated by these models? Well, I think this is a very important issue as well.
Yeah, right now we have on DALI 3, Midjourney, Still Diffusion as copyright free. It means we have a commercial use totally free because the copyright and the intellectual property is based on the how a human can copy my work. But we never thought that what happened if an AI is going to copy my work. And in copyright, we don't, we already doesn't write all these rules or something like that. We're working on that. But we have works like Adobe Firefly that gives some compensation or revenue share for
Mhm.
use all the works of that artist. And I think this is the way. I think this is the way that we can improve the artificial intelligence models with all those amazing artists, and also give the artist some like a revenue share or something like that. I think the way that Adobe Firefly is doing is the correct way. Some all of the big companies is working also on something like that. But
Okay.
this is so hard to control, and even
Yeah.
copyright is made by country, and this is a very hard work.
Yeah, I think that's true. It's a huge challenge in the copyright part because, as you said, we were not prepared for this, and yeah, governments are still working on that and determining what's best. The same goes to detecting which images are generated with AI, which I think also big companies like Google and others are working on this right now in marking and yeah, by saying people what images are generated with AI, so people know which ones are the real ones and which are not. So yeah, we have a lot of work to do there as an industry, and yeah, I look forward for contributing to this as well because it's a very important matter. Well, thank you, Carlos, for joining us. Thank you for this talk. It was really
Thank you.
interesting. We unfortunately don't have more time for other questions, but well, I'm sure Carlos is happy to answer any questions you may have in your AI Tuesdays. Is the Tuesdays, right?
Yeah, we have an streaming in Platzi is AI Tuesday, and every Tuesday we in the 7 p.m. Colombia time. We have a streaming totally open, talking about the all the new in the week and all the new trends and something like that. And also, you have my social network as arroba alarcon 7a. So you can write me here.
Great. Thank you, Carlos. Okay, we have to move on to the next speaker, the next talk. Um, Well, thank you, everyone. The ones that are just joining us, thank you for being here for our talk. Again, I'm Paula. I'm CEO of Linked AI. We work on the generation of training data to feed these algorithms. As Carlos said before, these algorithms need lots of data, lots and lots of data to train and to see how our world works, and we specialize in the generation of this data to feed these algorithms and to train these algorithms for object detection and for many other applications. um, I'm going to introduce you to our next speaker. Is Isabela Torres. So for our second talk, we have Isabella, she's a biomedical engineer specializing in artificial intelligence, currently pursuing a master's in science in artificial intelligence in medicine at the University of Bern in Switzerland. Isabella has experience as machine learning engineer focusing on developing and implementing customized software solutions for various organizations. She has been involved in creating models for machine learning, deep learning, and as well as database analysis for in programming with Python. Her passion for exploring AI applications in the medical field and drive innovation in healthcare has led her to actively participate in research projects, particularly in the analysis of medical images such as X rays and retinas using AI algorithms. So I think this is a great talk from Isabella. The name of the talk is From Pixels to Prognosis, exploring the impact of AI in transforming healthcare. So, welcome, Isabella.
Hello, everyone, and thank you very much, Paula, for your introduction.
Thank you,
I'm gonna
Isabella. You can
yeah.
take it from here. Yeah.
Okay, perfect. Thank you. I'm gonna share my screen, and then we can start. Okay. Good morning, everyone. I would like to start this talk with a thought-provoking quote that you can see on the screen. It says, "Artificial intelligence is not a threat to jobs. It's a threat to those who don't learn how to work with it." This message serves as a call to action for all of us. In today's rapidly evolving technological landscape, understanding and embracing artificial intelligence is not just advantageous, it's also essential. I hope that this message encourages all of you to start learning about artificial intelligence and building the knowledge that can later be applied in different scenarios. So, building on the theme of embracing artificial intelligence, let's now delve into a specific domain where AI is having a profound impact: healthcare. I'm excited to introduce the title of my talk that is From Pixels to Prognosis, exploring the impact of AI in transforming healthcare. On this slide, you will find a bit about me. As Paula already said, I'm Isabella Torres Revelo, and I'm a biomedical engineer. Currently, I am living in Switzerland because I'm doing my master's degree in artificial intelligence in medicine, and I am totally passionate about finding and exploring new ways of applying AI in the medical field so we can drive innovation in this amazing field. Um, let's take a quick look of our table of contents for today. These are the topics we're gonna discuss. I'm gonna start with the importance of correct labeling, as I know that Linked AI is one of the pioneers in this part. So, artificial intelligence has transformed operations in various industries, and healthcare is no different. At the heart of this transformation, it is a fundamental yet crucial task that is called data annotation or data labeling. Medical annotation and labeling are the processes of giving or attributing metadata to medical images so we can make them machine readable. However, there are some differences between the two. So for example, we need to understand what is labeling. And labeling is the process of assigning a single label to an image. This label can be as simple as a category, for example, saying it's normal or abnormal. But we can also have annotations. And these annotations are more complex than just labeling because we add more information to an image. For example, bounding boxes or segmentation masks. This information is super useful for training machine learning models that can help us identify and analyze medical conditions. There are also different types of annotation tasks. As we can see here in the image, we can have image classification, that is when we assign a label to an image based on the presence of medical lesions or anomalies. For example, in the first image, we can see a mass over there. We can also have object detection. This is a little bit more complex than image classification, because in addition of just adding the label, we also the artifact, the artifact in the image. And then we also have image segmentation, which is a task that breaks a medical image down in several components or smaller components. And we can find two types of segmentation. We have object segmentation and semantic segmentation. The first one focuses on labeling each object in the image with a unique label. And in the second one, we have the task consists on labeling each pixel in an image with a category label. So then why is so important this procedure? So we know that data labeling is essential for building efficient machine learning models. The accuracy and also the performance of these algorithms are highly influenced by the quality of the data with which they are trained. And also the annotation process aims to transfer human knowledge to the artificial intelligence models. So because we aim to summarize and also assign predefined labels to the data content. And also, as we know, machine learning models learn from data. Therefore, if we feed them with wrong label data, our result will also be incorrect. Moving forward with the second topic of the talk, I would like to share with you some of the projects that I have worked on where I applied artificial intelligence to medical images. So first of all, I would like to start with this project that consisted in training a deep learning model for the diagnosis of diabetic retinopathy. We classify this model was the model objectives was to classify several images of the retina into different categories or severity levels of this disease. And in addition, we also implemented some explanation techniques in order to give more information about the prediction that was obtained from the model. I would like to start explaining what is diabetic retinopathy, so we all know what is the problem that we are tackling. So diabetic retinopathy is a disease. It's a complication from the diabetes that affects the eyes. And it is caused by the damage of the blood vessels in the retina due to the increase in the blood sugar levels. Normally, we medical doctors use these kind of images to diagnose the disease. And the interpretation also of these images is done by medical experts. So this task has been proved to be time consuming and also very costly. And at the same time, it can yield erroneous or incorrect results due to the visual fatigue. So that is why right now we are introducing convolutional neural networks that can maybe improve the accuracy and the precision of these diagnosis, and also we can improve or make it faster in a way. So before moving to the architecture of the model that we trained, I would like to explain a little bit how was the data that we used. So first of all, we worked with a huge data set. It was at around 88,000 images of the retinas from both eyes. And this data set we found it in Kaggle, that is a crowdsourcing platform. These images were labeled by medical experts in 5 different classes. These 5 corresponding to the different severity levels of the disease. Also, the preprocessing of these images was very interesting because the objective was to highlight the vessels inside of the retina. So as you can see in the image, we have this preprocessing. I'm gonna activate the laser. So we started with this stage where we cropped and centered the retina, and also we remove a little bit the black background. After that, we all extract the local average color and we map the image or the brightness of the image to the 50% of gray. This was with the objective of highlighting the vessels, as you can see here. But also this gave us a problem because we can see this highlighted border or edge. So then we need to subtract it with this mask here. And in that way, after doing this process, we were able to obtain these kind of results of retina's images. Um, Also here you can read the full procedure that is from this author. Then the deep neural network that we trained was composed by 30 layers. It was a combination of convolutional layers, max pooling layers, some dropout layers for regularization, and also fully connected layers. At the last fully connected layer had an activation function called softmax, which gave us the probability of each image to be in a specific class. Very quite often, these deep learning models are considered as black boxes. This is because they don't give enough information about what is happening at the interior of each model. So we don't know exactly how they got to a prediction. So that is why it's very important the interpretability and also the explainability of this kind of model so we can build trust on the prediction they are giving. So in this project, what we implemented that also research was this technique that it's called GradCam. This technique, I'm gonna explain a little bit how it works, but also like a big picture. This technique is for visualizing and also highlighting the regions of importance that contributed the most to the final decision of the model. How it worked. For example, here we have in the last convolutional, in the last fully connected layer is where we get the score or the prediction of the model. So we take this score and we also take the activation map from the last convolutional layer. The activation map are just images that have all the features that explain that are or compose the images. We assume that a convolutional neural network has a hierarchical learning. That means that each of the layers learns a different feature from the input image. And taking the activation map from the last layer means that we are going to take the features that are more complex and more abstract. So that is why they are the ones that, let's say, summarizes all the information from the input image. We take them too, and then we calculate the gradient. This gradient just indicates how each feature map affects the final prediction score. Okay. After this, we global average pool these gradients. I know it sounds very complicated in mathematics it is, but just for making it more clear, it's the meaning of this is that we are going to measure or have as a final result the importance of each of the pixels here, and we are going to have this as a simple number. Okay, so we know how much important each of the pixels from this activation map were. And once we have this information and also again the activation map, we combine them by weighting their scores. And at the end, we will have, or we can visualize these scores or these numbers as a heat map. So you can see here the red parts are the scores, the higher scores, the ones that contributed the most to the final decision. Finally, also overlay this heat map on the input image, and then we will see the regions highlighted in different colors, okay? We can have here I'm going to show you some results that we obtained from the network. These were some images part of the test data set. And we can see the class which the model chose to give to these images. So they both are from the severity level 4, that is the severest stage of the disease. And we were able as well to compare them with a medical expert who gave us his feedback. So what we can see here in this image is that, of course, it's clearly visible lesions around the retina. But these lesions, and also you can see that the heat map is highlighting all that. That is why this model classified this image in the severity level 4. But then when we asked the doctor if that was correct, he said, yeah, I mean, of course, it's very notable this, but in fact, these are not characteristic lesions of the disease. They are scars, and those scars are produced by a procedure that is called pan-photocoagulation. And this procedure is applied to patients who have like a very severe health state. So then in fact, these scars aren't as that the disease is still there because it was already treated. So then with this feedback and also with this other feedback from this image, for example, here we can see that the heat map is highlighting this part or this region of the image, where we can see some characteristic such as microhemorrhage or microaneurysms and hard exudates. And in fact, the model is highlighting that. So it's like that this image in the severity. But when we asked the doctor, he said that he will focus his attention, for example, in this part of the image, which corresponds to proliferation of new vessels that they are not normal. So in this case, this means that this person or this patient is very severe because this creation of new vessels can be dangerous also for the eyes. So this feedback was very helpful for us because it could give us more information about how to tune and retrain the model so we can learn from these mistakes, let's say. And also it's very important to have these uh, feedback from medical experts so we can also contribute together and also find or create better solutions. Okay, that was the first project, and now I'm gonna share with you a little bit more about another project that it was more like a tool created for the detection of pneumonia in chest X-rays, also using convolutional neural networks. So here I'm gonna explain what is pneumonia, but in a very short way. This is a disease that affects the respiratory system and the alveolar spaces of the lungs become inflamed. There are many microorganisms that can cause this disease, such as bacteria or viruses and also fungi. So this problem was to try to classify or to differentiate the images from which microorganism was causing it. So then we work with a data set with different images labeled as well by medical experts in 3 different categories: normal bacterial pneumonia and virus pneumonia. In this case, we also pre-process the images as well, but in a different way, because what we wanted here was to highlight the interior of the lungs. So what we did was, of course, reshape and crop, but also utilize the histogram. So it was to work with the contrast and the brightness so we can highlight the interior of the lungs. The architecture of this model it's smaller than the previous one. It just has less convolutional layers, and also the, let's say, the dynamics is the same, because we have convolutional layers, max pooling layers, and then the fully connected layers. In this project, we also applied the GradCam technique to check what were the model learning and how can we improve it in cases that it was making mistakes. The added value of this tool, of this project, was the design of a system that could also interact with the user. So we created a tool with an interface and also with modules that can be triggered by the user, and in that way it becomes as well like a real tool. So here I am showing you some of the results and how the interface looked like. And it was very easy forward and user friendly. So the things that the user needs to do is just to upload the image that he or she wants to analyze. It was also possible to introduce some information about the patient. And then it was just to click in the button that says predict. In a few seconds, you will receive the result with the heat map overlaying on the input image. So the user can know what were the regions that the model thought or the model thinks is the more important regions or features. And also we have the classification and the accuracy of the classification. As well, it was good to save all the results or the interactions, and then it can be exported as a PDF, so you can have a track of all the patients or tries that you have or tests that you have done. Okay. This is not all. I mean, this is just for medical images, but there's a broad range of applications of AI in medicine. And right now, I'm gonna give you like some use cases that are very important and also interesting. So if you are like surprised or inspired by them, I encourage you to read more and find more information about it. So I have defined that there are, let's say, three big branches of applications of AI in medicine. So the first one, it is called AI-based medical diagnosis. So here, use cases that I have found very interesting and also that can make a change in the future. So for example, as I said before, with medical images, we can use this diagnosis for screening and diagnosis disease with the assistance of AI using images, laboratory slides, or sensor data. We can also predict and prevent readmission in hospitals, taking into account all the demographic data and also the available data that we have in healthcare. We can also manage chronic diseases and drive clinical decision support tools for medical doctors. There's also another big branch that it's called healthcare information management, because in this part it is not all related with a diagnosis, but with the management of all the healthcare information. I am talking about electronic medical records or prescriptions, healthcare and billing records. So you know that healthcare also works as a company, and there are many institutions that may be benefited by artificial intelligence. because we can streamline workflows, for example, using voice recognition or optical character recognition. We can also automate a lot of processes with RPA by means of making it automatic and faster. And finally, we have the other branch that I call digital health solutions. And this is like having a personal advisor every time. And I think it facilitates a lot the um, the access to healthcare. So first of all, we have the real-time patient data collection and monitoring for emergency care. So that means that you can bring to home some devices that can monitor your health state, and then they can be sent directly to healthcare institutions or medical doctors, and they will save time because you don't need to transport there. But also we can use a lot of app-based mobile applications, or even the wearables that we have today, that it's also called the Internet of Medical Things. We can constantly track our vital signals, and we can also have recommendations, predictions, or maybe prognosis of what is likely to happen, or what should we do next. There are also a lot of solutions that take into account XR, that are uh, all related with virtual reality, augmented reality, and there are many applications for pain management and rehabilitation. And there's also very interesting applications about chatbots. We have ChatGPT right now, but it can be also developed a bio ChatGPT that is just for answering questions related with the health. So I hope that these applications and use cases are very surprising and interesting, and maybe encourage you to go further and read more, and also get a lot of get super interested about it. So this is all for my talk right now. I'm open to answer some questions that may arise, and I really appreciate that the invitation, and also I hope that you have learned. Thank you very much.
Thank you, Isabella. This was great. I think this was a great example of why AI should be applied in healthcare and how it's being applied and the importance of it. I also think that it shows the important part that plays working together and the close working between machine learning engineers and the medical professionals. I think this part is fundamental and paramount for a good development of these applications. So I think this is a great example. That the training data and the data labeling is a huge challenge, and it's very important for these models to work as they should. So
Yeah,
it's
exactly.
this is very important part of the process. And well, for the ones that join, there are people still joining at this moment. So at Linked AI, we specialize in providing this ease of mind to companies that require lots of data and label data to train their algorithms, even in the healthcare industry, because it's a great challenge, because you need the feedback from the professionals, you need quality data, you need not also the challenge of collecting this data, but also labeling it, and then we provide this feedback loop between the companies and the professionals. So I think this is very important, and this is a great example of how data labeling plays a very important part in this process. So I think we have many questions actually. So
Yeah.
go ahead and choose first
Okay.
one. So the first one is what advantages that does GradCam have over other feature visualization techniques in the diagnosis of retinopathy?
Okay. So GradCam is a very easy technique to implement. So that would I would say is one of its main advantages. It is not just for retinal for diabetic retinopathy. It can also be applied to any kind of networks, and I found it very useful because you don't need to train again the network to get these feature maps. You can implement this technique after you train the network and every time you are testing it. So I think that that's very convenient because you don't need to, let's say, it is very costly efficient and also is not computationally costly. So I think it's a very good technique. However, there are many others novel techniques that I think can bring more information and also more detailed results. So of course, this was like it was on the rise a couple of years ago. It's evolving so rapidly. I think right now there are many others applications that we can discover.
Interesting. We have another question regarding data augmentation, and I think there are two of them. So the first one says, what data augmentation techniques are used to improve the robustness of AI models in retinopathy diagnosis? And I'm going to go ahead with the next one because I think they're both related.
Mhm.
So since medical images are almost always the same, like in the same format, size and resolution. Regular data augmentation, like rotation, escalation of the image, could represent a problem. So, how do you see like data augmentation in this kind of projects? How do you use it?
Okay. So first of all, I would like to mention that the medical images, they are not always the same. In fact, they are very difficult to work, and they are super different in format, size, and resolution as well. So we can have very big images, and we can, because they come from different medical devices. So each provider has a different format for the medical images. We can have DICOM, we can have Nifty, and like every provider processes them in a different way. So then this is really the challenge when you are working with medical images, because first you need to understand how your data is, how the images are, and then you can think like what would be the best techniques for data augmentation. So of course we need to know when to use data augmentation. So first, when we don't have enough data, so that will be the main reason. But we can not just apply whichever technique of data augmentation we think, because sometimes we can damage the nature of the medical images. For example, we cannot flip them or do something like that because we will lose the anatomy of the medical image. So we need to take into account what are the features we want to identify first, and what will be the objective of augmenting. So I think that let's say the basics ones would be rotation and also zooming. We can also a little bit of noise, and that would be great. But then the other ones, you need to think a little bit more if they are necessary or not.
Nice. Yeah, and I think those may apply or not depending on the case, as you said, because not all images can be rotated, or adding noise may, yeah, damage the
Also be
image.
a problem.
So it's a huge challenge. It's not like any other object detection application, but these are images that come with lots of challenges.
True.
And a big challenge as well is data collection. So we have another question from Rob. How
Yep.
difficult is it to collect quality data sets for medical applications?
Okay. I like this question because I think it's a tricky one, but also interesting one. I think it's very difficult to collect quality data sets for medical applications because, first of all, we need to understand that the data doesn't belong to us. It belongs to the patient. So right now, of course, there are many models that can work, but they were trained with open source data sets. Um, so if from now on we want to build new models, we need to first count with the pay. So if we want to build some models, we need to ask for permission first. So that would be one of the challenges we need to, we are going to encounter when building these kind of data sets. Second of all, I think that it's very difficult as well. If we want to build a real model that works for many people, there we need to consider a good sample or a good data set that can represent the, let's say, the population uh, we are pointing to. So this is very important because normally the models that are trained right now, they can have a lot of bias, and this is because they were trained with a specific kind of people. So this is very important to take into account in medical applications because the least we want to do is to harness the patient or people. So then we will need to guarantee that, let's say, like free bias models, which is very utopic to say, but I would say will be something very great to have. In this way, we don't also transmit the same unfair society, let's say, to the models. So we
Yeah.
can impartial results. So I think it's very difficult, but not impossible. If we work, as you said, and as you mentioned before, the collaboration between different institutions is very important. And also transmitting, or yeah, the importance or the, let's say, like the that we will get at the end will also give more peace of mind as well to the patients so they can start sharing their data, and also the medical practitioners can also encourage and be open to receive different solutions, and in that way the collaboration, I think it will be the most important for making AI have a part in healthcare.
Thank you, Isabella. I think that was a great answer. It covered everything, even the bias that it represents a huge challenge in, well, in AI in general, but
Mm-hmm.
here in the healthcare space, it's very important to have free biased AI. So yeah, I think that's a huge challenge, and it's very difficult to collect this data and to label this data as well. But as you said, it's not impossible. There are professionals working on this, and um, the work between companies, public sector, the private sector, the machine learning engineers, and the specialists in the healthcare space. It's very important to foster these kind of applications. So thank you, Isabella, for joining
Of
us
course.
in our second and our first day of our webinar. Thank you, everyone that joined us today. Thank you very much, Isabella, Carlos, for participating in this first day of our webinar. I hope everyone enjoyed the session as much as I did. We look forward to seeing you tomorrow. We have a second session tomorrow that is going to be in Spanish, 10 a.m. New York time. We will discuss generative and artificial intelligence further applications, and we will have another talk on medical AI, which is going to be very interesting for the people that want to hear the talks in Spanish. We hear you. We have for the first time, we have talks in English and talks in Spanish tomorrow. So I hope you enjoy them, and I hope you can participate in both days. So thank you again for joining us, everyone, and I hope to see you tomorrow.